In last class, I have discussed about the cantilever sheet pile. Now, in this class, I will discuss about the anchor sheet pile. Now, the idea of this use of this anchor in a sheet pile is that as I have already discussed that the difference main difference between the or normal retaining wall and the sheet pile is that in the retaining wall the depth of foundation is less compared to the sheet pile, where the sheet pile the most of the resistance is coming from this foundation depth. So, the required depth is very high as compared to the retaining wall, but sometimes to reduce this required depth is anchor is used. So, this type of sheet pile is called the anchor sheet pile. So, now first if I go for this anchor sheet pile condition, so similar to that this is the top ground surface, this one is the dredge level, and this is the cantilever sheet pile. Now, here sometimes to reduce this required depth, one anchor is used here. So, this is this that means this here applied tension is applied with the this is the sheet pile, where this tension is applied through this anchor, then it is anchored in the ground. So, now here this type of sheet pile, that is called anchor sheet pile. Now, here this is basically the anchor, this one is anchored within the soil. Now, that means additional tension or force is applied. Now, here when we do the analysis, that means ultimately here also similar to the cantilever sheet pile, you have to determine the required depth of this sheet pile below the dredge level. This is the dredge level. Now, here two methods that is applied. One is our free earth support method, these are the analysis methods. One is free earth support method, another is fixed earth support method. So, two type of analysis that we can do, one is free earth support method and is fixed earth support method. Free earth support method, here we assume that surface this end is free. So, now if I consider the first free earth support method, then the deformation shape of this sheet pile is considered like this. So, that means it will deform in this form, and then this will be the shape. Now, if I consider two different types of soil, one is first we will go for the granular soil, and next we will do for this for the clay soil or cohesive soil. So, we need do this analysis for this free earth support method in granular soil, and we will do the analysis in the cohesive soil also. Now, first that we will do this analysis for the free earth support method. So, first we will go do for this is for the granular soil. So, if I consider one anchor sheet pile in the granular soil, so this is dredge level, this is the sheet pile, this is the top ground surface, this is dredge level, where this sheet pile this applied force is applied here, that is the F force which is applied due to this anchor, and this is the required depth of the foundation below the dredge level. Now, the water table condition, suppose this is the position of the water table, this is the groundwater table, position of the groundwater table. Now, the load distribution diagram that we can do, that this would be the expected diagram. Of the, see, this is the earth pressure diagram corresponding to the active passive combination. So, here F is applied here, then this force will act in this direction and this will act in this direction, opposite direction. So, this is the earth pressure diagram of the sheet pile. So, this is sheet pile. Now, these are the different position. If this is A, this is base is the B, then this is dredge level, this is E, we can consider. So, first these are different components. Here we consider this one, this distance where earth pressure is 0 is at a distance of A from the dredge level. Now, this earth pressure at this level is P, A is the active earth pressure at E level. So, P A E is the active earth pressure at point E or at level E. E is this point. Now, distance of this remaining part, if I consider capital Y, so we can write that D is equal to A plus capital Y. So, the forces, so that means here what are the forces? We can consider this as the two parts. One is this portion is, this is active zone and this is the passive pressure. Now, if I take these two different force, that means what are the forces that is acting? One is F due to this anchor force and another is the P active and another force which is active, that P passive. So, the forces those are acting here. So, first one is F is the force due to the anchor and then P A is the force, or you can say active earth pressure, force due to active earth pressure, and P P the force due to this passive earth pressure. Actually, this is the net pressure we can say. So, now these three forces that will act in this total, these three forces means if I consider this is O. So, one region is A, E, O, this region, that is P act A, another is O B in this region, this is P P. So, now if I write this is this anchor rod of force due to the anchor, and now we can write that this F plus P P minus P A, that is equal to 0. So, this among these three forces F plus P P minus P A equal to 0. Now, as I have discussed already in previous class during this cantilever sheet pile, we can determine this A value with this expression, that is P A E divided by gamma at this level below the dredge level, if I consider gamma dash, into K P minus K A, where P A E, this is the pressure at this E level, gamma dash weight of the soil below dredge level, and K P is the passive earth pressure coefficient this is passive earth pressure coefficient, and P A is active earth pressure coefficient. So, these are the things. So, in this expression, by the help of this expression, we can determine the forces this distance A. So, this is our expression, and this is our general force equilibrium expression. Now, if in this other if I draw the same figure here, so this is sheet file, it is the top level, it is the dredge level. Now, this is the groundwater table position. So, forces that is acting, this is the F anchor force, this force is P active, and this is P passive, this distance is D or depth. So, this is the A, E, O and B, and this point, this is the P active at E level. This distance is A, remaining one capital Y. Now, if I take the moment at anchor rod level or anchor level, that is equal to 0. So, now this force P A, say, is acting at a distance of y 1 bar from this rod level P A, and P P is acting at a distance of y 2 bar from the rod level. So, y 1 is from the rod level, this is P A, and P P is acting y 2 bar from this rod level. Now, we can say that our P A into y 1 bar, that is equal to P P into y 2 bar. So, this is the expression if I take the moment at the rod level. Now, how will calculate this P A or P P? Now, P P we can calculate because this P value, this value is given by this expression, that gamma dash into K P minus K A into capital Y, because these things already discussed in during the cantilever retaining wall calculation. So, this is the net force or net pressure, this K P minus K into gamma dash into capital Y, as this is the distance capital Y. So, P P will be half into gamma dash K P minus K A into capital Y into, so this is capital Y into capital Y. So, this will be half gamma dash K P minus K A into capital Y square, and Y 2 bar will be Y 2 bar, that will be that if total height is h, say, and the distance from the dredge level to the rod level is small h, total height of the sheet pile above dredge level is, say, capital H, and position, the distance from the rod level to the dredge level is small h. Then we can write capital Y 2 bar will be small h plus A plus 2/3 of capital Y. So, this is Y 2 bar. Similarly, we have to calculate the Y 1 bar by taking different components, this small triangle, then this rectangle, then again this triangle, and then the remaining triangle. So, this how to calculate this Y 1 bar, that has been already explained in example in the last class. So, that thing has already been explained. So, in this way you have to determine the Y 1 bar and the P P also. Now, putting this Y 2 bar everything in this expression, say suppose this expression 1, if I put everything in the expression 1, then we can write that P A Y 1 bar, that is equal to half gamma dash capital Y square K P minus K A into H plus A plus 2/3 of Y. So, further if I simplify these things, so we will get capital Y cube gamma dash K P minus K A divided by 3 plus Y square gamma dash K P minus K A divided by 2 into H plus A minus P A into Y 1 bar, that is equal to 0. So, in this expression, this final expression, if we look this to this final expression, then what are the unknowns here? The gamma dash is known, the soil property K P K is also known, then this A is known, A we can calculate the expression which is shown. H has to be known, because we should know the position of this rod level from the dredge level. Then P A we can calculate, Y 1 bar also we can calculate. So, only unknown is Y, this capital Y. So, first we have to determine the capital Y from this final expression. Capital Y, once we get the capital Y, next step we will get the D, that is capital Y plus A, and once we get this D, this is increased by 20% to 40% by providing this factor of safety. So, once we get this d value or capital Y value, then what we can do? We can this P A we can calculate, because this P A is the top portion where A we know we can determine, P A we can calculate, and if I know Y capital Y value, then we can also calculate the P P. So, once we know the P A and P P, then we can calculate this F force, anchored force, that is P A minus P P, because that force is required. So, we have to design this anchor such that it can sustain under this F load. So, so this way we can determine how much depth, required depth we can provide for this anchor sheet pile, and what is the required anchor force. So, this analysis is valid for granular soil. A similar one we can do for the cohesive soil also. So, next one is for the cohesive soil, how to do this analysis for the cohesive soil. So, again this next one is for the cohesive soil, then so, we will do this analysis for the cohesive soil. So, we will consider same sheet pile, but the soil is different. This is the top portion, this is the dredge level. So, required depth is D. So, here the same, this is the position of the water table, this is the anchor force that applying F. Now, here the difference is that here we consider in the previous one granular soil, we consider that our foundation soil and the field soil, because this is a field soil and this is the foundation, both are granular soil. Here we consider that this is the field soil is granular soil, where we consider Cu is 0, and the soil below the dredge level or foundation soil, that is cohesive soil, that is phi u is 0. So, or you can consider the both in C phi soil also, there the pressure distribution diagram will be different. So, now here we can consider similar diagram for the, but here for the granular soil we will get this type of distribution instead of this triangular one. So, how we will calculate this forces? So, this is also again this one P active at E level. So, this is A, this is B, this is E, and here the forces that is acting again this F, then this P active, and again this P passive. So, again this F anchored force, active force and passive force. So, these are the forces that will act, again say distance between this anchor force from this rod level to this active force, this y 1 bar, and this is for the passive force, this is y 2 bar, this is y 1 bar, this is y 2 bar. So, now when we try to calculate the what are the forces at different level, then we can get this value this way, that for this passive pressure, if I go so passive pressure diagram, that is Q bar K P plus 2 C u root K p. So, this is the common expression to calculate the passive pressure at any point. Similarly, this is P active, that is Q bar K p minus 2 C u root K p, where K p is the passive pressure coefficient and for that C u is the cohesion, undrained cohesion. Now, for phi u equal to 0, this K p equal to K a, sorry, here this one is K a active. So, this is the K p is the passive earth pressure coefficient and K a is the active earth pressure coefficient. This is not the K p, this is K a. So, K p minus K a, that is equal to 1. So, at the dredge level, now this Q value we can calculate, the Q is the effective overburden pressure. So, Q bar is effective burden pressure. Now, if I want to calculate what is the active earth pressure and passive earth pressure at this point E at dredge level. So, there is a two part, one is the left part, another is the right part. So, now if I consider that at dredge level the right point, the right side of point E, the Q bar value is, if this is H again, H is the height of the sheet pile from the dredge level, then that will be gamma into H. This is where this is effective, this gamma into H, or as this water table is here, then we can calculate in other form also, that is if this height is, this is H 1, capital H 1, if it is capital H 2, then we can consider this density is, if it is gamma and this is gamma dash, then this will be gamma into H 1 plus gamma sub or gamma dash into H 2. So, this is the unit weight, this is the submerged unit weight of the soil and this is the unit weight of the soil, its natural condition. So, in this way we can determine, but it is gamma dash H for this calculation we are considering. So, now we can put that P A E, this P active at E level, that gamma dash is equal to Q is equal to gamma dash into H. As for this dredge level, below this dredge, this portion, this phi u equal to 0, we are considering that phi u equal to 0 for this portion. So, at this level the stress that we are taking, that phi u, and if I consider this phi u equal to 0. So, K p will be 0 for this level. So, now we can write that K a is equal to 1, as if phi u equal to 0, then K p equal to K a equal to 1. So, this is gamma dash into H minus 2 C u. Similarly, at the left hand side, of point E, Q bar is 0, because here no surcharge is there. So, Q bar is equal to 0. So, you can write that P P E, because here the passive earth pressure P P E, that is equal to 0 plus 2 C u. So, that is equal to 2 Cu. So, at this point dredge level, the right side the active pressure is gamma dash H minus 2 U 2 Cu and the passive pressure is 2 Cu. So, net pressure we can write that net pressure that is equal to P P E minus P A E. So, that is equal to 4 C U minus gamma dash H. So, P P E at E and P A E. So, 4 C U gamma dash H. So, the net pressure that we are getting at this level, that is 4 C U. So, this is the net pressure. So, that is 4 C U minus gamma dash H, that is the net pressure. So, now if I draw this same figure, so we can draw, this is the sheet pile, this is dredge level. So, this is water table position is here, this is anchor force F, so here net pressure we have calculated, this one is 4 C U minus gamma dash H, and this is the P A E, that is E position, this is A, this is base B and this is the rod level. So, forces which is acting, that is P active and this is P passive. So, this distance from the rod level to P active is y1 bar and this distance from the rod level, this is P y2 bar to this point. This is D is the required depth of the sheet pile, H is the height of the sheet pile, capital H. Now, again if I want to find the P P first, because P A again we can calculate P A and how to calculate this y 1 bar, that is also been explained. So, that part is fine, but we have to calculate this P P, that P P is here 4 C U minus gamma dash H into D, where D is the depth of the sheet pile. D is equal to required depth of the sheet pile. So, now we can write this is expression say 1 and then summation or of the moment which is taken at the anchor level, that is equal to 0. So, if I take the summation of this anchor level, that is P A into y 1 bar, that is equal to P P into y 2 bar. So, we can finally, or we can write P A y 1 bar, that is equal to P P is 4 C U minus gamma dash H into D, and the lever arm is, if this is the small h from rod level to dredge level, the small h plus D by 2, because it will act at the center which is a rectangle. So, this is D by 2. So, finally, we can get this type of expression, d square plus 2 d h minus 2 p a y 1 bar divided by 4 c u minus gamma dash H, that is equal to 0. So, the final expression is this one, where which are the unknown P A we can calculate, which is total force due to this active pressure. Y 1 bar also we can calculate, C u and gamma is the soil property, H is known. So, only unknown is D. So, what you have to do? Then you have to determine the D from this final expression, then increase it by 20 to 40% due to the factor of safety. Then once you get this D, we can calculate the P p, then the finally F will be determined by P a minus P p like the previous case. So, these two are the different two cases where previous one is the granular soil and it is cohesive soil. As it is in the cohesive soil, then this phi u is 0. So, K a is equal to K p is equal to 1, that we are using. So, in this way we can analyze this anchor sheet pile for the granular soil and the cohesive soil, but here we have taken the free earth surface support method, where the next one that I will discuss, where this is analyzed, we consider the fixed earth support method. So, for next we will discuss the fixed earth support method. In that method, that the next one is support method. So, that means here we consider this is our sheet pile, this is dredge level, this is the top surface. Okay. So, that is the dredge level. Here this is the anchor, this is the force, anchor force, and this is A, this is E, this is base B, and this is the rod level D. Here if I go for this deformation pattern, then this will be the deformation pattern for the sheet pile. Here that means the difference is here one point of contrafracture will appear. So, here this point is, say, this is the point of contrafracture. That means, here the bending moment, if I can draw the bending moment diagram, that bending moment is changing its sign, or here it will go from positive to negative or vice versa. So, that means, here bending moment diagram, if I draw the bending moment diagram, this type of case. So, this is the total sheet pile we can consider. So, these are the same points. So, this is, suppose this is I point of contrafracture, and then we can draw this type of bending moment diagram, say here at A, this is at D, this is at E, the next one is I point, this point say I point, and this is B point. So, we can get this, we may get this type of diagram, where So, here this bending moment is changing its sign at this point of contrafracture, and then we will get this type of diagram of the sheet pile. So, this is our fixed earth support method, or this is the different position, or we can say. So, this is I and this is the diagram of different points. So, we can say in here also we get different points where we will get say this another point G. So, there also we will get this G point, and then we can get this type of diagram also. So, that is our the same, this is the friction force that you are getting in the opposite direction. If I draw this diagram, so this is our anchor position, then this is the dredge level at the I, this is the point of contrafracture, then you will get at G level this value, and also you will get some this type of pattern also. Okay, so, that means you will get this type of bending moment diagram for the soil for this fixed end anchor pile. So, now, so this is the our BM D, and this is also deflection pattern. Deflection pattern. So, now we will discuss how to analyze this system, because here this is, if this is the different type of, this is the point of contrafracture where these forces are changing, this is the G is another point. So, now if I get, so this will be the G value is somewhere here, and then you can get this type of diagram also. Now, if I go for the pressure distribution diagram for this type of sheet pile, then we will get, so suppose this is the sheet pile, this is dredge level. Now, the pressure distribution diagram we are considering that again this is A, this is the anchor point D, this is E, and this is B, then one position is I, which is point of contrafraction, then below that this is say G. So, now if I get this diagram, you will get the granular soil. So, this is the diagram where at the G, suppose this is the maximum, then you will get another change, then you will get this type of diagram in the analysis. So, here this I is somewhere here, say this is I point, this is the where this is maximum, this is G point. So, this is G point, I is somewhere here. So, this is the diagram. Suppose this is H is the height of the sheet pile. Now, here somewhere F is acting, which is the force of the anchor force, and then this is the required depth below the dredge level. So, we will get this type of distribution of the pressure distribution in this case. So, here also this is say A, this distance is I, say. Now, from this total system, we are considering only this up to G portion, and if I draw this diagram for the G portion only up to G, then you will get. So, this is the G value, G point, this is say I point, this is the E point, this is the D point, this is the A point, this is the I point. So, you will get this type of diagram. So, this is I point is here somewhere. So, when as we are taking this portion, then we will get another reaction that will act is R G, and this is the force will act at F. So, then what are the other forces? Then similar to this is the P active for this region, that means this is A, D, E, I. In this region, this is the total force A active, and then the next force is then this force in the opposite direction, this force P passive or P 2 that will act. Now, here suppose at I 0 point this force is P 0. So, these are the, and this pressure is P A E, the pressure at E level. This is the pressure, P 0 is the pressure at I level. So, once we get these forces, then we will get basically two, if I consider two different beams of this total portion, then this again if I take this, if I consider draw the same figure here up to A to G, then this is the dredge level E, this is the D level where force will act F. So, this is G level, this is I level. So, here this force is P 0, at E level P A E, and G level one reaction R G will act. Now, for this one, if I draw the bending moment diagram, this is the pressure distribution. Then, if I draw the bending moment diagram of this total portion, so this is the at D level, then it will follow at I point, point of contraflexion it is 0, then it will go at G point, it is maximum. So, this is A point, this is I point, this is E point, this is D point, and this is G point. So, this is the bending moment diagram, because this bending moment diagram is a similar diagram that I have previously drawn. That means, this is the forces, then I at I it is 0, then G we are taking up to G portion. So, this is the point, here also we are taking up to G portion. So, that means, if I consider only up to G portion, so this will be the bending moment. This is just in the mirror image, you can the opposite side. So, this is in the G portion. So, we will get this is the bending moment diagram. Now, we consider this total portion is taken to divide into two parts and two different beams. So, you can consider one beam is from A to I, another beam is from I to G. So, we consider these two beams, one beam is from A to I. So, this is our beam number 1, and this is our beam number 2. Because the sheet pile you are considering this is two beam, this is one is A to I, another is I to G. Okay. Now, what are the forces in the first beam? So, that force F at D level, that force will act as anchor force. Then this reaction R 1 that will act at the I level. In the beam 2, opposite reaction R 1 will act at beam level, and this reaction R G that will also act at G level. So, these are the forces. Then additional to that, in beam 1 and beam 2, the force will also act due to this earth pressure. Okay. So, that means this is F, R 1, R 2 and R g. Now, due to the, if I consider the forces, this is the forces and then this beam 2, then in addition to all other force that will act, if I consider earth pressure also, because of this additional earth pressure some forces will act. So, what are these forces that we will draw here? So, that means the forces that we are talking about. So, first we will draw the earth pressure diagram of this A to G portion. So, the forces, this is the dredge level E. So, we will take, this is the earth pressure diagram here. So, then it is your maximum, then it will follow this path. So, this is the diagram we have drawn. So, this point is say I, where moment is 0, and this is G point, and this is D point where this F is acting. So, now we have taken two beams, one is from A to I, another is from I to G. Okay. So, now what are the forces that is acting here? So, from the A to I, so the first force from this beam 1 is acting F, anchor, another force is acting R 1, reaction, the similar opposite reaction is acting here R 1, and here R g is acting. So, now the forces that is acting for this, for I A to I beam. So, this force from this acting, so this will act as P 1. So, P 1 is the forces due to this area's pressure. Similarly, this beam, so one pressure will act here because of this small triangular pressure. This is in the second beam. So, this is a beam 1, this is beam 2, and so that means P 2 will act here, and this side for this triangular opposite direction one pressure P 3 will act. So, if I take separately this beam 1, what are the pressure? So, this is the beam 1, the pressure is acting, this is beam 1. So, one pressure is acting F at a D level, then this reaction R 1 that will act, and this force P 1 that will act, force for this earth pressure. Now, for the beam 2, so this is A to I. Now, for the beam 2, what are the forces that will act? This is I to G, this is beam 2. So, this reaction R 1 also will act here, one reaction R g is also act, because this as the reaction, because we are taking the some segment, not the total beam. So, this is some segment. So, this is R 1 is this R 1, because this is beam 1 beam 2. Then additional force, this P 2 will act, this P 2 is due to the small triangular force which is acting this side, this is also acting this side, and this is also acting on the opposite side. So, another force P 3 that will act here. So, these are the forces that will act. Now, we have to calculate all these reactions, all these forces, then we can determine how determine this D value. Now, these are the forces diagram for this in the force this diagram on the different beams. What are the forces acting, what are the reaction forces, what are the external forces acting here. Now, with the help of these forces, we have to determine the required depth of the sheet pile and anchor force. So, how to determine this depth of the sheet pile and the anchor force, that I will discuss in the next class. Thank you.